Now? Hey, everybody can hear me, I hope? All right, let's get right into this, guys. Today, as the title suggests, we got a couple of case studies here that we're going to be talking about secondary air injection systems. Now, not every vehicle out there on the road is going to have secondary air injection. It is an emissions add-on, I guess I would call it, mostly found on California compliant vehicles. Now, before we get into the class, I have a pretty awesome announcement to make for you guys. For those, our Spanish-speaking audience out there, you maybe have noticed that we've been not doing any Spanish broadcasts lately. Well, that's because we've been transitioning, and we have a new Spanish instructor here in the building. His name is Peter. Peter, why don't you come on out here? I'd like to introduce you to you guys, our newest member of the Wells Tech team, Mr. Peter.
Hello, everybody.
So why don't you just real briefly tell us about yourself?
Well, I'm about 20 years in the business, turning wrenches, ran my own shop for almost 10, and I taught at BOCES, which is a tech school back in New York, for about 6 years.
Okay, so you're coming to us all the way from New York, which was hard to tell, you know, with the accent.
Yep, loving this Wisconsin winter.
Yeah, it was chilly this morning, a little bit of snow on the ground, but yeah. So Peter is going to be starting doing some classes in January or February when we start on the next series. Today he's going to be helping me out with starting up this BMW behind me. We're going to do a car swap in the middle of this, so he is going to get the car out and bring the Trailblazer in that we have next. So you'll see him around helping out today. But otherwise, for the Spanish-speaking audience out there, make sure to check back for some Spanish classes starting after the first of the year. All right?
Excellent. Looking forward to it. Pay
Perfect.
attention, guys. Lots to learn today.
All right. Thanks, Peter.
Thank you.
Oh, and apparently my laptop is saying I have a critical update to install. Let's hope it doesn't boot me out. You want to bring up the laptop screen quick just so everybody realizes that I'm not lying to anybody? We have a critical update to install, so hopefully this does not... Are you ready for these? No, I'm not ready. So hopefully that doesn't kick us out. All right, let's start right in on it, guys. As the title suggested, we are working with some case studies. But before we get to that, I want to do the tech question. Let's bring that back up on the screen. Technician A. Oh, first of all, guys, this one is maybe just a hair easier than you're used to. But it is the holiday season, Christmas just around the corner, so I want to hopefully give away some shirts today. Technician A says that a fuse will blow as soon as the amperage going through it is higher than its amperage rating. Technician B says it's common for a circuit to momentarily pull amperage higher than the fuse rating without compromising the fuse. Who's correct? A, Tech A, B, Tech B, C, both technicians, or D, neither? I'd like for you to go ahead and shoot me out an email to my email address right here. And if you could do that by the end of the day, you will be entered into win, or you will win one of our shirts if you get the answer correct. Okay, the t-shirt giveaway is only valid for today, though you're more than welcome to always comment in the answer to see if you're right. You can only win a t-shirt if I get that email by 11:59 p.m. tonight, okay? Alrighty, let's just make sure that everything's coming through in the comments. Nice, hey, there we go. All right, a lot of people here. Looks like Eric's here. How's it going, Eric? I think I said hi to just about everybody else as we were waiting and chatting. Mike's here, Porsche Mike. All right. Should totally change your screen name to Porsche Mike. Hector's here, Zach's here. All right. Oh, looks like Keith made it. All right. All right, guys, let's get into this because I do have a lot I want to talk about today. And there's a lot of moving pieces today. The cars will be going up and down. Cameras are going to be moving. It's going to be a crazy fun day. So let's get right into it. Just a quick overview on secondary air. It is designed to force air into the exhaust system because cars are notoriously running rich at cold start because they're an open loop. Just part of their nature, I guess. That's what they do on cold start. So what do? We pump extra oxygen into the exhaust system, and it is intended to help light off the catalytic converter sooner, therefore increasing the efficiency of our vehicle so we don't kill the ozone. One thing to note on secondary air injection systems is we need to, as a technician, always make sure that we are diagnosing not only the cause or not only the effect of the problem, but also the cause. Many times with secondary air, you'll have one part failing, but it's being caused by another part. you know, like where potentially a worn spark plug could cause a coil to fail or something like that. You have to replace everything that could be causing the issue. You know, not like, what else is a good example? Something, you have a worn out wheel bearing, you just replace the wheel bearing, right? You know, there's going to be more to these replacements. So we'll get to that in just a little bit. But the number one, I think probably the number one failure that we're going to find is water intrusion on these systems. Many of our air pumps are either mounted underneath the vehicle, like we'll see on the Trailblazer, or in the wheel well, like on this BMW. You can see that we already have the fender liner ripped out of here to help save some time, but the fender liner's sitting on the floor over there. That does take, I don't know, 15 minutes or so to rip out of there. And you'll see as we look under the hood, I got a bunch of other stuff taken off as well to help save some time when we're looking at this. A real quick component list on here, guys. Air injection systems will usually consist of an air pump. Older vehicles would run it on a belt. Newer vehicles are going to use a high amperage pump that moves a high volume of air. 20, 30, 40 amps is not uncommon for an air pump to pull, so we have to have a high current relay that's going to be controlled most likely by the PCM. And then we have to have some sort of control valve because we cannot let the exhaust pipe sit open all the time. We can't let that allow to force exhaust back into our air pump at all times. We only want to open that valve when we're actually creating pressure with our pump. So we have a control valve on there that is going to be doing a flow or no flow basically into the exhaust. Now that control valve operates many different ways. We'll talk about 2 different ways today. We have the hoses and pipes connecting it, and then we have to have some sort of verification of flow. So similar to EVAP, we have to be able to test the system for failure, right? Anything OBD2 has to be tested for failure. Some vehicles, 2005 5 Series behind me here, is going to use a secondary air injection mass airflow sensor, standalone mass airflow, not part of the mass airflow sensor for the engine, a standalone mass airflow that is only measuring the air going into the air pump. That's what this BMW runs. Then if we get into our Trailblazer, which we'll be bringing in just a little bit, that is actually going to be using our oxygen sensors to watch for a lean condition to be created when that air pump happens. The Trailblazer will actually test in closed loop, and it'll turn that pump on for 3 seconds, 3 different times, watching for a lean condition to become present across the oxygen sensors, meaning that we're actually flowing air through the system. I mean, we have to be able to verify and test the system. That's where the check engine lights come in. Your P0401, P0411, you know, manufacturer-specific codes get into like P1411, 1412, 1418, 2430, 2440, P014, already said P012, 412. So there's a lot of codes. That's just on the BMW here. There's going to be more related to that. Unfortunately today, guys, it doesn't look like I'm going to have access to all data. For whatever reason, I'm not sure if it's down for you guys, but it is down for me. But I do have printouts of diagrams, and we can grab diagrams here from Identifix. So first of all, let's take a look at the wiring diagram for our BMW that's sitting behind me. So up on the screen here, it's going to be kind of small. Let's go ahead and zoom in. You can see our 3 air system components. We have our pump over here, which is direct grounded behind the right kick panel apparently. That runs back to our relay, which is, for whatever reason, here's a little bit of extra credit. I'll give you another shirt. If you can answer this question accurately as to why this part of the relay right here, why is it when this relay is off, is it run to ground? What is the purpose of running this to ground when the relay is off? Why would we ground both sides of our secondary air injection pump? When we turn the coil of the relay on, it's going to activate our relay, which is a direct fused input, which comes from off of the screen, but that is from a 60 amp fuse, and that's going to send the power. This is going to switch over, send power directly to our air pump from that 60 amp fuse. But again, why is it that we have this directed to ground? It feels like, to me, this wire was added in for maybe a different model. Maybe it was just something they already had in there. Don't know. It seems unnecessary, though, to have to run a wire here to ground. Most of the time, you'll see this pin right here pretty much going to nothing. It open circuits it at that point. Turn the coil on, bring the switch over inside the relay, and run that high amperage to our pump, which goes directly to ground. And then over here on the left side, we have our airflow meter. It is a hot film airflow meter. And if we look here, it looks like black and yellow is going to negative. So black and yellow will be the ground for our meter. Pin 3, black and red, is going to be our signal. So I already have that back probe to help save some time today. We will monitor that on the lab scope. And then red and white here is going to go to either the PCM or a fuse. In fact, I think I have the other diagram here. That is going to go to a 30 amp fuse that also tees off to a bunch of other things. That 30 amp fuse also feeds the control side of our relay here. Let's see if you guys can see this. Unfortunately, I didn't have this copied and pasted today because I expected our service information to work. But you can see our mass airflow sensor there running from a 30 amp fuse. We get a splice, runs over to the control side. This guy right here is our air pump relay right here. So the PCM commands that grounded and turns on our air pump like so, okay? That is the way this system operates. Now this vehicle came in today with a check engine light. Customer complaint is check engine light's on, there's no drivability concerns, nothing like that for the system. It just is a check engine light on and he is unable to pass emissions. So let's take a quick peek at our codes. And apparently we have a misfire code here. Interesting. This was not here last time I scanned this thing. Now this vehicle's been here. I diagnosed it about a week ago. Or maybe a week and a half ago. So when I first looked at this, if we can bring up the scan tool, this misfire right here, and cylinder 1 misfire was not in here. So that's going to be another problem maybe for another day. Or maybe this customer was messing around with this car, who knows. But that is not the complaint today. The complaint today is we're talking about this 2761 code, which is actually a 411 code. If we go back here, let's see. Some vehicles you can get generic functions out of here. It doesn't look like we're going to be able to do it on here. Let's go back real quick and turn this into a generic scan tool so we can get an actual generic number. Because sometimes it's easier to find information generically rather than looking up the other way. So let's see. And Peter, you got the key on in there, right? Thank you. He is sitting in the vehicle right now, hopefully not falling asleep. So lucky that Jim doesn't have to sit in the vehicle this time like he did in that other class. It's upside down. What's upside down? Something's upside down. Okay. So we got this pulled up. And we're just going to grab mode 3 for DTCs. And we should, in here, see a P0411. There we go. P0411, air system incorrect flow detected. So the Varus does a little bit better job of telling us what is happening here. But then you could go out to your service information, which I did in this chart right here, which I was hoping to be able to pull up on the screen today. But as you guys can tell, on the laptop, I can't get there. So let's just pull up the laptop real quick. I can't get there today, unfortunately. But I'll read off of here what this is saying. It says here a P0411 is the low flow limit check. It basically is watching the signal from the mass airflow sensor. And it says here the threshold value is delta air mass. So the change in air mass is greater than 0.28 grams per second. Now, the greater than is kind of weird. I think it might be something that might have been lost in translation. I would think if we're checking a low flow limit rate, we're looking for an airflow that doesn't change or less than. I think it was just lost in translation. You know, we see that a lot with European and Asian vehicles where things just aren't maybe translated out correctly when they're done in English. So I think what we're looking at here is the change in air mass. So the computer's watching our mass airflow sensor and it's looking for this test to change the air mass more than 28 grams per second. And if it doesn't, if it sees under that or if it sees less than 0.28 grams per second, well then we're going to set a code for a low flow limit. Okay? There's a couple different thresholds here for enable conditions. We want to see coolant temp below 69 degrees, underneath 3,600 RPM, and then this is a 2-trip code on here. So what do you do first? Well, I like to do the easiest thing first, which on a BMW, it's kind of hit and miss on what's easy and what's not. Luckily, the scan tool will allow us, what am I doing here? The scan tool will allow us to command this thing on and off. If we want to bring up the scan tool on the screen now, that'd be great. See if we're getting into, here we go, grab a beamer, 05, this is an 05 530i with the 3-liter in there. We'll get back into here. And what I want to do first, I'm just going to command the relay on. If the relay turns on, the PCM is commanding that half of it, and we should be turning the air pump on. It is direct grounded, so as soon as the relay turns on and we make contact across that relay, our air pump should, in theory, turn on. We'll go back into engine, and we'll go functional, actuator tests, and we'll grab the secondary air pump. Ignition on, engine off, that is correct, right? We're good to go. And unfortunately, we don't have any data PIDs on here. You know, it'd be really nice to have a data PID on here for the mass airflow sensor for secondary air, right? Look at the grams per second that the mass airflow sensor for secondary air is actually flowing, but we don't get that. So we'll turn this on and off. Start, stop. We'll see if I can, I don't know if you guys can hear that. So it is definitely clicking. Let's bring up this camera. The relay is going to sit right here. And as I turn this on and off, trying to get my microphone as close as I can here, guys. But the relay is definitely clicking. But you know what I don't hear? I don't hear the pump turning on. And with this high amperage pump that's on this thing, you will definitely hear it when it comes on. Even if it's mounted behind the splash shield or wherever it might be mounted, you will hear these things come on. They are pretty loud because they're moving a vast amount of air. So I don't hear it coming on. I guess at this point we have to figure out what's going on. Our relay's clicking, so at this point, would you bother inspecting the relay? It's kind of a choice that's up to you. What's easier to get to, the relay or the air pump? The relay's clicking. Do you go there first if it's clicking, or do you just move that relay further down your list and go right to the air pump? Now, for this class today, guys, I do have the relay box completely available for you guys to see up here. It was kind of a pain to get to. There's a cover that sits here, then there's another cover that sits over this that blocks all of this off, and then there's a cabin filter that sits over that. It's kind of a pain to get to. So maybe in my diagnosis, when I'm doing this, if the relay's clicking, I'm probably not going to go there first. I'll probably work towards the pump first and see if I have power down there. The other thing I wanted to talk about here, before we bring this thing up in the air, I'm going to go ahead and move the coolant bottle off to the side so you guys can see in here. But right here is our valve. This is the valve that's going to control flow out of the pump into the exhaust, or not allow flow. So this is a mechanical valve on here that operates under spring pressure. Our pump has to overcome a certain amount of pressure to open this valve and allow our air to flow out of the pump and into the exhaust system on here. This does not have a vacuum hose going to it. This does not have power and ground going to it like a solenoid. This is completely mechanically controlled by pressure. Now, I tested out a new one. It does open at roughly 2.5 to 3 psi of pressure to get this guy to open up. Okay? And then also, if you look down in here, I know it's going to be really hard for you guys to see, but right where my finger is right here is our filter assembly, and you can see I have a lead already hooked up to the mass airflow sensor that is sitting right inside of there. So our filter on this system is sitting right here. It's got a standalone tiny little air filter. It's about this big around, and it's got a filter element in there just like any old air filter. You know what, why don't we pull that off? It only takes a minute. That way you guys can see what it looks like. Now these filters usually stay pretty clean because if you figure either it's a BMW driving around with a check engine light on and nobody decided to fix it anyway, or the pump itself doesn't run all the time, right? I mean, we're only going to run a minute or two usually at the most when this thing's cold, and then it's going to shut off. not like your engine air filter that's going to constantly have air flowing through it. This is not going to be constantly working. So the only time it's filtering air is when the pump is running. Let's see if we can get this thing off. Okay, so the mass airflow sensor just disconnected. If we can maybe you guys can see it now. Let's take a look at the overhead shot. Yeah, you can see my lead. Kind of hard to tell. Now let's see if I can get this filter out of here. It's mounted on a rubber grommet, and the mass airflow sensor is a single bolt to get it out. I think it's a T25 Torx. Probably disconnecting my lead right now. There we go. All right. And like with every good BMW, things come out nice and easy. Nice cooler line or AC line mounted in the way, but here's our filter. Bring it over so you guys can see. So our mass airflow sensor mounts directly to here. With this screw, it's going to mount directly on there. And then we have a filter element inside. Let me grab a flashlight. All right. So if I can hold this at a decent angle, you can see a reddish orange. I know it's really hard for you guys to see, but there's a reddish orange filter element in there, and if you guys could see it as well as I can, it's not really that dirty. It doesn't look bad at all. Now it's up to the customer at this point if he would choose to replace it. I did a quick look around out on Google, and this thing is getting hard to find. It's actually been discontinued, I believe, by BMW, so good luck finding one of these brand new, but this one seems okay. It really does. It's not full of dirt or anything like that. I don't have anything coming out of it at all. If it was black inside, if it was full of sand or something like that, I'd probably be more prone to replace this. Now, if you've done the work of already getting it out, it might be worth replacing it. Because in order to get this guy out, I did have to pull off. This right here is the front cover that sits over the radiator. It's where the hood latches mount to. So that did have to come off. It really doesn't take too much time, but it's just another one of those, got to take off 3 different things to get to what you're actually trying to get to. Typical on a Beamer. Okay, I think it's to the point now where we should lift this thing up and check our power and ground to our pump. Let's just see quick if I'm missing anything. All right. All right, Chris, you win. I think there was a thing out there to see who could make me laugh first, and Chris was nice enough to put on here, nice butt. So thanks, Chris. That's ridiculous but funny. I like it. All right, let's get this thing up in the air. I'll show you guys where the pump is located. All right, that looks good. Let me bring the camera over, guys, and we'll take a look at our pump. Now let's grab a flashlight so you guys can see in here. All right, how's that? Hey, you can see what's going on. Good. Well, that's a good start to the day. All right, so normally in here, guys, you'd have your fender liner and all that fun stuff in the way. Fortunately, that is already off and sitting on the floor over there. So it takes, I don't know, 10, 15 minutes or so to rip it off. There's like 13,000 screws holding it in. It's slightly over-engineered. with about 7 other shields that have to come off. But that's besides the point. We have it off, and we're getting to our pump right here. Big old wires run into this thing, guys. Like I talked about, high amperage to this pump. 30, 40 amps. We're going to run some big old wires going to it. Like we talked about in that counterpoint video where I was showing the different soldering connections and butt connectors and those kinds of things. You can really start to stress the wire once you start flowing a lot of current through it. This is no different. We can really stress this out. So let's just make sure that we don't have the pump actually running. Turn this on, off, on, off. Pump is not running. I don't hear anything running. Let's go ahead and unplug it. And let's grab a meter and just see what we got with a meter. My wife wants to retire in Germany. I better pay attention. All right. Nick, that's a good point. If it could be a scanner issue, but Nick, to talk about your point here, if the scanner wasn't commanding it properly, I wouldn't think I would hear the relay click. Right? The scanner's job is to tell the PCM basically to make our relay turn on. And I know for a fact that the relay is clicking, which usually means that it's turning on. Now that doesn't verify that I have power flow down to the pump, but it does verify that the coil side of the relay, the command side of the relay, is taking that relay and switching it over, which should, in theory, send power down to the pump. So, with that being said, let's see if I can find somewhere good to stick this where you guys can see it, where there's not a lot of glare. How's that look? That's pretty good. Let's see what we got here. I'm going to go ahead, I'm going to turn the pump on, and it'll apparently stay on for 20 seconds. Let's just see if I have power and ground. I'm just taking my 2 terminals, my meter, going across 11.7 volts. You guys should be able to see that. I'm just connected across the 2 leads of the connector. So I do have power and ground. But at this point, guys, I don't know if this is a good power and ground because we are not dynamically testing this. We are statically testing it. I have not verified in any way that I can flow any current whatsoever. So I know the relay is turning on. I know it's sending power down there. But am I able to flow current through this thing? So what could you do? You could hook up a new air pump, or you could put some sort of load into the system. Now, an air pump is an extreme, I would call it an extreme amount of load on an electrical system. Your test light is going to draw roughly a 1/4 amp or so. I don't think that's going to be a good test for this. You want to have something roughly the same as an air pump. So if you have a blower motor or something like that laying around, that'd be something good to use. You guys saw this bulb in our class. This is only running 6 amps, so it's not anywhere close to the 30 that this thing might run on. But at least it's something that's able to draw some current. So let's just see if this guy works. All right, let's see if I can do this in 20 seconds. I started it. We'll set this up here, hopefully not have it smash on the ground, because that would be just my luck. I mean, it's going to happen live if it's going to happen at all. And there we go. You guys should be able to see. I'll move it out here. So, and there it just turned off. The PCM, or the scan tool, just timed out. It will only run this for 20 seconds. I'll do that one more time. I'm going to end up dropping it and smashing it on the floor. Okay, super fast. Here we go. Again, power and ground, running roughly 6 amps through this bulb right here, okay? So we are able to flow amperage through the relay down to our pump, and good to go. Hook it to the starter. Oh, jeez. I don't think that's the best idea. All right. So, just making sure I'm not missing anything here, guys. Okay, so now we know a couple things. One, our relay is functioning. We have a good ground. We're able to flow 6 amps through the circuit. It's not as much amperage as this pump requires, but it is a pretty good amount. So what do you do now? Write up the estimate, call up the customer, sell the pump, right? Okay, that might be the way you want to go, and let's see how that would turn out. Customer approved it. New pump sitting here. Okay? It's time to install this new pump. First thing, let's take off our hose connections at our pump. So right up top here, this guy right here, This is our inlet to the pump. It comes into the top side of the pump. This is connected to our mass airflow, which maybe I can pull through here. The wire's too short, but you guys can just barely, oh, you can't see it at all. If I would unplug the connector, you'd be able to see it. But that's our mass airflow sensor up there. So I need to unhook this guy at the top, which is usually easier said than done. Let's see. Try not to get in the way of the camera. Looks like I got one of them loose. Let's grab a pick. So you can pop this other one. Sometimes a pick helps. Just don't break this, because otherwise you're going to have to replace part of this hose. And I hope I didn't just jinx myself. All right. See how that looks? Well, it's not broken. That's a good sign. Plastic is still intact. And so you're supposed to be able to pinch this together. And it's supposed to, move these tabs outwards as you pinch it together. One thing to note here, guys, is as I took this off, there's a little bit of water in it. Okay? So we got water on the inlet side. That's maybe not a good sign. Could be from a little bit of condensation. So let's get this guy out of the way. And let's pull off our other hose. Let's try and get this light over here. Maybe. There we go. So now we're going to pull off the outlet side. This is going to be the side of the pump that's going to force pressure into the exhaust. Let's pull this guy off. Oh, whoa. I hope you guys saw that. This pump's full of water. That's not good. So now you've sold a pump. The old pump was full of water, but what caused the water to get there? What is the issue here that's causing us to have water full of it inside of this thing? This thing is full of water. A couple different things could be happening. One, the pump's seals, wherever they may be inside of here, might be failing. Two, the guy could have pressure washed under the hood and sprayed directly into his filter, which worked its way down the inlet, into the pump, and then out of the outlet. Possible also. Or it's possible that the valve that sits on the exhaust manifold or on the head on this one is partially leaking maybe, or is having issues, and it's allowing some hot exhaust gas to basically sit inside the hoses and down inside of our pump. Now, it's not a ton of pressure coming out of our exhaust in a normal operating system. Like tailpipe pressure is not very much. But it's possible that that hot exhaust gas could be getting itself down inside of this pump and then condensing. And when it condenses, it creates water, moisture problems. There's a lot of different issues possibly here. But this amount of water that came out of this thing, that is no bueno. We cannot have that on this thing. Our pump is almost 100% certain that it is seized up inside from that water. But I also have a feeling that our check valve could be causing us some issues. But let's not take my word for it. Let's hook this guy up and see what we've got. All right, so we'll plug it in. And you know what? Let's see if we can get this old one out first. Maybe we can dump some more water out of it. I don't want this thing to hang by its connector. Left this under the hood. All right, let's see what we got. Oh, and just to note, guys, I did find my 10 millimeter short socket that I was looking for during that class where I was doing that trans range sensor. Found it. And actually, when I took the splash shield off on this thing, there was a socket sitting in there as well. Somebody had dropped it at one point when they were working on this car. All right, whoa. So there's a little bit more water coming out. And the third one. I can't believe these aren't breaking. It's my lucky day. I didn't even spray them with any penetrating oil or anything. Did you guys know that they make a set of just 10 millimeter sockets? You get your 10 millimeter short, your 10 millimeter long, a swivel, a 3/8, a 1/4 inch. I think there was another one too. It's like to replace all your missing 10 millimeters instead of having to buy a full set. Thought that was genius on somebody's part for that. Okay, let's see here. I have a feeling I'm gonna have to, oh, that is a lot of water. Feeling I might have to pull this wire connection off the bottom of the pump. There we go. And hopefully sneak this guy out of here without taking the bracket off. Well, maybe I shouldn't have taken a shower this morning. Okay, so here's our old pump. I don't know if you guys can, I don't know if you can hear that, but it's sloshing back and forth. I mean, this thing is full of water. It's junk. You know what? I think in the Tech Connect episode that's going to come up at the end of the month, I'm going to set this down before I make a mess, more of a mess. In that episode, guys, I am going to have that thing taken apart. I want to see inside. I want to see what it looks like inside because it is definitely pretty nasty. Now, if I trip and fall and all this water on the floor, don't laugh at me, please. Might be kind of funny, though. Anyways, let's get this new one in that's not full of water and see what happens. So, like so. And then it does only go in here, it's supposed to only go in here one way because we have to connect up our outlet hose. So it's going to look something like so. Beautiful. Okay. Let's just bolt this guy down quick. Ugga-duggas. Torque to spec. All right. So we'll torque those later. Okay, so our pump's installed. Let's get our connector mounted on its bottom bracket here. Plugged in. And let's just connect it up and let's do some current measurements on here. All right, that one's clipped. These always go back together easier than they come apart. Make sure it clips in place. There we go. All right, pump's installed. Both hoses are connected. Like I said, I already have the scope hooked up to the mass airflow sensor. So let's plug that in. And then I also have a current clamp here that we're going to measure the amperage coming out of, coming out of our pump. Let's peel some tape back here. I will retape this when I get done here. Don't worry. Nice fiber tape on here. Get enough room between here to get the amp clamp in. That should be good. All right, let's take a look at what we have. Zero this out. Hopefully the amperage is going in the right direction. I can see the rims corroding from here. You know, I don't know if you can see. Let's bring, yeah, right here. When this thing originally came in and I pulled the wheel off, this was all corrosion here. I had to scrape it down a little bit. And it does need some anti-seize on there or something to help with that. Okay. All right, Eric, we'll see you later. Thanks for stopping by. Okay, let's check our amperage on the pump. Got the scope booted up here. I am using a big amp clamp. I'm using a, I think we gotta scroll down. Let's bring the lab scope up on the screen. I'm using this is a 2000 amp clamp. I'm gonna use it in 200 amp mode. And let's grab, well, this thing's supposed to run, the fuse is set at 60, so let's run it at 50 amps. Let's turn on channel 2. I'm not sure if this is a 5 volt or a 12 volt sensor, so we'll start with 20 and we'll tweak from there. All right, it looks like our scope is good to go here. Let's go ahead and turn this on with the scan tool. You guys can hear it running. That's a good sign. and we'll turn it off. All right, let's stop it and go back a couple pages for that initial turn on. Whoa, so right there it's peaking off the screen. So we're over 50 amps. Let's go ahead and do this again with a 100 amp scale. Turn it on. Still peaking off the screen. Wow. Okay. Stop. But you guys notice something already? We have no change off of 0 for our mass airflow sensor. So either I have a bad connection or we have no flow. Try it one more time here, see if we can catch that peak. Oh, I think I turned it on in between the buffer. Come on. Bad luck. Let's just up our time scale a little. We'll go 1 second. Okay. Look at that, guys. Look at this peak. 105 amps. See that? 105 amps peaking on this thing, on the initial turn on. It takes, let's throw some cursors up here. So from time it turns on to time we're under our fuse, we're 60 amps on here. We'll call it, right about there. So 61 amps, close enough. It takes, we'll just do it rough here, 420 milliseconds. So just under half of a second, this circuit is sitting over 60 amps. Now our fuse on this thing, like you saw in the diagram, is 60 amps. So if you haven't answered the question already, there's kind of a hint. So this thing is able to pull 100 and, what I say it was, 105 amps right here. Crazy. But I don't have anything going on the red line from our mass airflow sensor. So it means one of two things. Either I have a bad connection, which I didn't pierce this, it is back probed, or I have no flow. So we'll start by tweaking our connection on here. Luckily, I can get through to the engine compartment from this side. We'll tweak that a little bit, turn this guy back on. And on the scope, we still don't have anything. Let's bring up the scope on the screen. There we go. Nothing. Wiggling the connection. Okay, so it looks maybe like we have no flow. Let's go ahead and take our output hose off. Okay, so now our output hose is off. All that's connected is our inlet hose, which is connected to the mass airflow. This thing is just going to force air out here. And let's bring up the scope on the screen and let's see what that looks like. Get the keyboard out of there. And I'll wait for it to refresh on the next page. Hey-oh. Okay. Well, that's a big difference. Let's go back a page. So now, what is our amperage peaking at? Our amperage peaks at 100 and, well, we're still around 105-ish. But now you can see that we definitely have flow. Here I was putting my hand over the outlet. So it looks to me like we have a bad part in our system. Our valve is most likely the culprit here. So like I said early in the class, guys, you need to make sure that you diagnose the entire system, okay? So I'm going to bring this thing down, and we'll take a look at that valve that's mounted under the hood. Now, if everything goes right here, maybe, if everything goes right here, I'm going to leave all this connected here, guys, and we're going to look at that valve and then run this thing once we get back under the hood. Okay. Hopefully Peter's not sleeping. You fall asleep? No, he's not sleeping. Good. I don't know if I could be as strong as you. I'd be napping. Okay. So like I said, our valve is mounted right here. Now, a quick, easy test that we could do. Let's just pull this off. This is our hose going to it. This is coming out of our pump, which is now connected at the other side on our pump. Let's turn this thing back on. Turn our scope on, and our scan tool will turn it on. All right, that was quick and easy. So we have flow. We know that our hose right here, we know this hose is not blocked. We know that we have flow through this hose. I bet our problem is lying right here. Let's, I believe there's two 10 millimeter nuts on there. We'll pull that off, hopefully not drop them. Hopefully they come off. Oh, almost dropped it. There's one. And two. Okay, so this is what it looks like up close and personal. Tiny little valve. And as you guys can see, nowhere on here is a vacuum port. Nowhere on here is a solenoid that you're going to connect to power and ground, okay? One thing to note, inside of here, this is all corroded in here. I don't know if we're going to be able to see. Again, this might be something that you guys will have to come back for the Tech Connect episode to see, but tons of corrosion inside of there. So the water most likely affected this valve as well. Now, what about after the valve? What about the exhaust system itself? Could it cause problems? Definitely. We could have a problem in the exhaust system. Peter, could you go ahead and fire this thing up? What we're going to check for right now is for outlet exhaust gas coming out of this hole right on here, because this should be, we should be able to feel exhaust coming out of here just like it'd be out of the tailpipe. Okay, go ahead. Oh yeah. All right, you can turn it off. So it actually kicked our air pump on. That's funny, but I could, and I'm sure you guys could hear it, it sounded like a giant exhaust leak. We have exhaust coming out of there. That means that after the valve to the exhaust system is free of restriction, it is time to put a new valve in, which just so happens to be on the table next to me. Now, I don't know about you guys, but I like to verify parts. So this old one, we're thinking we can't do anything with it. And that's true. I can't blow through it at all. The new one, again, these take about 2.5 to 3 psi to open. I can definitely blow through it, but it is hard to blow through. It's not a stuck open valve, but it is hard to blow through. The one other test that you would want to do for this is you would want to start the vehicle up, and we'll do it in just a second, but start the vehicle up with this valve attached and make sure that you're not having any exhaust gas come out of it. That would mean that the valve is leaking. So there's two failures, I guess, a stuck closed valve or a partially stuck open valve. Okay, so we're going to go ahead and install this guy back on here, our new one. And now, after the class is over, guys, you know, we're not going to put the fender liner and stuff back in today. I'm going to clean up the mounting surface for this thing. It does need to be cleaned up and a new gasket installed, but just for time constraints today, guys, I want to just do this very quickly for you guys so we can move on to the next vehicle and not waste everybody's time. The diagnosis is true in here. Just when you're doing this, you'd want to clean up the mounting surface that this thing mounts on. All right. And tighten this one down. And Peter, could you start this thing up one more time? I want to make sure I don't have any exhaust gas coming out of our valve. And our pump turns on. Okay, that's good. So this thing keeps trying to turn on the pump, but it definitely turned on and I had no leakage coming out of there. So connect up our hose and let's just run it one more time with the scan tool and make sure now with the system fully intact, this thing flows. Oh, look at that. All right, hang on one second. Let's throw a channel 3 on here. I want to show you guys the time delay that this thing takes. Where can I grab a ground? How about maybe right here? Everything's painted under here. Let's try this. I want to just grab voltage here, hopefully. And let's see if that's right. So channel C here, our third channel, is going to come in, and that's going to be the voltage command. There we go. So our voltage is commanded. All right, here's what I want to show you guys. Look at the command time here. So our relay clicked on, our PCM turned it on right here. We see our green channel come up to battery voltage. But we don't see our flow happen until, change between here, delta between here, 867 milliseconds, which is just under 1 second. So it takes almost a full second for this pump to build enough pressure to overcome the spring that is in this valve. Now this is known good. These are 2 brand new parts on here. You guys could treat this as a known good design. You want to see that, you want to see your pump control and your current or your spike on mass airflow. You want to see that in roughly 1 second or so is the time delay between there. Temperature will most likely affect this, but you want to see it happen roughly in that amount of time. If you're seeing this happen, way over here, it's taking, 4 seconds for this thing to open and start to see some mass airflow movement here, you might have a seizing or sticking outlet valve, okay? We want to see this happen. We want to see our mass airflow respond roughly in a second or so from turn on of the pump, okay? All right. I think that maybe is just about everything for our BMW here today, guys. What do you think? Are there any questions, comments, concerns related to this BMW? Does anybody want to see anything else? Chris's internet quit. He wants to start over. Not going to happen. My throat is going to be raw by the end of this. But Chris, like always, you can always view the video afterwards. So any other questions, comments on this one? Keith's talking about cleaning the passages. That is a good idea, the speedo cable on a drill. I've seen that before. There's actually a company out there that makes a tool for doing a lot of these on BMWs, which is basically that. Can we run the monitor on here, I wonder? Let's see. Oh, I think, did you turn the key off? Okay. The key's off already. Okay, no, that's fine. We'll just move on to the next one. It's already been 55 minutes. Sorry, Keith, we're not going to run the monitor today. The scan tool's already disconnected and the key's out. So we are going to move this thing out, though, and we're going to bring in the Trailblazer to go over that secondary air system. It is a little bit different. We got a different failure on there. So Peter's going to go ahead and get that hooked up and taken care of for me. Thank you, Peter. Let's see here. If there's anything else that I've missed, you guys are very talkative. I just want to actually copy these comments because I don't want to lose them. Pete is excited to move on. He was stuck in that car for a while. 45 minutes in there and I probably would have been napping. Looks like I might have missed some of the comments. You guys are talkative today. All right, let's scroll through. You can bring the comments up on the screen, Glenn. Thank you. Hook it to Ivan's homemade Christmas tree lighting. Yeah, we could have done that. Bob says water. Imagine that. Just goes to show how many times air pumps have water in them. Eric says water pump or air pump. That's a good point. For some reason, these things are just so common for water in them. Frank's got 5 10-millimeter sockets. Yeah. Air system needs a catch can. That's true. I was thinking it could use one of those bleed-off valves that bleeds off pressure when it drops, or bleeds off when it's a low pressure, like on a air tank system, like in your garage. You get under 5 psi or something, and it allows the valve to drain. All right, let's see here. EX Motorsports, Kevin said he's 50 amp fuse. On this one, it is running a 60 amp fuse. Mike said, wow, magic, the parts show up right away. All right, let's, I agree. I think it should get a drainage tube. I mean, really, guys, these systems, we all know it already. They're so common for water intrusion on them. They should have some sort of drainage built in. You know, it would probably increase the longevity of these things like crazy. Yep, I agree with you, Keith, that valve being stuck open, allowing exhaust to end up down into that pump. All right, Peter's going to bring in the Trailblazer, and we're going to get to that. Now, in the meantime, let's go over a little bit of the system. Let's see if we got any all data functioning. Okay, unfortunately not. Ooh, the camera gets screwy when we open up the garage doors. It's nice and sunny outside, as you guys can see in wonderful Fond du Lac. No snow on the ground right now, but it is nice and sunny out today. Sunny and cold. All right, let's bring that back over. So let's talk about our Trailblazer. Let's first of all grab a wiring diagram. Now, my favorite part about this Trailblazer was the amount of information they actually had for this thing. So this is a 2005 Trailblazer with our good old straight 6 4.2. And we'll just grab a color diagram. And find somewhere in here, here's our secondary air injection solenoid, we'll grab that. All right, what do we got here? So right here is our secondary air injection pump relay. All right, that's going to be running directly from a 60 amp fuse. Let's zoom in on this so you guys can see a little better. 60 amp fuse directly running to our relay. When the relay is turned on, it switches our contacts over, sends that 60 amp capable power down to our pump, which is directly grounded on the left rear of the frame near the fuel tank. There's never going to be any rust or corrosion there at all. And then our relay here is, I'm going to assume, ground side controlled by the PCM. We could trace this out and find it. And then here's our solenoid relay. This guy is powered up by 15 amp fuse 54. This is powering up a relay that's going to control our solenoid for our air injection. So on this Trailblazer, instead of it being this, let's go ahead and reset the camera. There we go. So instead of it being a mechanical valve like this, it is actually an electronic solenoid that is opening and closing by computer command, like a purge solenoid or something like that. All right, we good? Thank you very much, sir. Key on, scan tool in it. Prop rod. Thank you, sir. Okay. Okay, so I think you guys should be able to see okay here. I've already taken the air box off of this thing. Let's see if we can turn these headlights off quick. There we go. Otherwise, we'll end up with a dead battery. I've already taken the air box off here because what I want to do is I want to show you guys the solenoid on here. 8mm. All right, pop that off. Now, right here, guys, this is important. Right here, this is the inlet to our pump. Like on our BMW, we had it connected to its own air filter. You can see on this vehicle, it is connected in line going to our engine, okay? So we're gonna take filtered air through our engine air filter, and it is gonna be drawn into our pump that way. Okay, so Looking at this thing, I already see something interesting. This guy's been replaced. Brand new part, not from me. Our solenoid has been replaced on here. Let's see if we can get a closer shot. Do, 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 do. All right, so right there's our solenoid. This is going to be opening and closing the path to the exhaust. So just like our mechanical solenoid that was opening and closing the path, that's what this guy's going to do electronically. The computer's going to command it, 2 wires here. But this one is already brand new, so somebody's been in here playing around on this thing before. Go figure. See that all the time, right? All right. So, as you guys can hear, the alarms are going off in here. That's all right. Let's grab the engine computer and let's take a peek at what codes we've got in this thing. All right, we got a P0410 trouble code. Something to do with secondary air injection, which we kind of already knew. Now, let's take, and I wanted to show you this up on the screen, guys, but unfortunately, this is still not functioning. I don't know what's going on over there, but something's not working with our other repair resource, so luckily I did have it printed off. GM is awesome. They gave us a full page and the top of another one with specs related to the secondary air injection system. It says here, I'll just read some of the highlights, that this system is going to function when the vehicle coolant temperature is between 37 and 122 degrees Fahrenheit, and the IAT has to be greater than 32 degrees. So we don't want this thing starting up when it's frozen. Water issues, frozen inside of a pump could cause damage to the system. Now I like here that they actually give us specs. It says the air pump for our 4.2 liter engine will draw a steady 35 to 40 amps under normal operation. If we look at, we must have had that turned off at that point. Darn, I thought I had that. Well, if we looked at our current on the BMW, it's probably about 25 amps or so was what we were pulling. I don't think that's, yeah. Okay, well, we had it on there. I don't know if maybe a clamp fell off or turned off at that point, but whatever. It was pulling 25 amps or so, so we'll see what this air pump pulls. The other thing is that it tells us about our air shutoff valve. This electronic solenoid under the hood is 4 to 7 ohms, and it should run at 2 to 3.5 amps to open up that solenoid. So it's nice that they give us this, these specs, right? It's nice that they have that. So the customer complaint on this thing is intermittent check engine light, and intermittently it smells like something's getting hot. When he pulls it into the garage, it smells like something's hot, almost like burning plastic. Something just isn't quite right with this thing. He said it's been happening for a little while. He pulled the codes and he installed that part on there, but to no avail. So, same thing with this thing. We're going to go ahead and we're going to run a functional test, and we're going to try and turn this air pump relay on. So as you can see on the scan tool, actually we'll back up one here. As you can see in here, we have air pump relay, but nowhere on here do we have air pump and then air pump solenoid. It's not, there's not 2 different controls. This thing will actually turn on both relays with one command. All right, so on, off, on, off. I can hear the relays clicking. I bet you guys probably can't right now because of the alarm. But if we go under the vehicle, we should be able to hear these relays clicking on and off. I can definitely hear them. So I guess at this point, it's time to go down to the pump again, right? We're turning the relay on. It's commanding on, but I can't hear the pump turning on, and maybe it's too loud in here right now. I'm not sure. But let's go underneath and see what's going on with this one. Now the Trailblazer is kind of nice. It is relatively easy to get to. You don't have to take anything off to get to the pump. It is mounted on the frame rail right near the ABS module. And hopefully we don't hit the camera. All right, there we go. Let's go underneath, and first of all, let's grab the flashlight and take a peek underneath. So this thing's supposed to be an underhood light, but it kind of works nice under the car as well, against the tires, like so. All right, let's take a peek at what we got here. All right. So you guys can see, there is our air pump. Nice and easy to see. Hoses going right to it. These are our inlet and outlet hose. So just like our air pump that was on our Beamer, the inlet is actually marked with an arrow right here. That is our inlet going into the pump, and here is our outlet. Peter, would you mind turning the scan tool on and off for me? So he's going to go ahead and click this on. Our relay is actually mounted right back here. All right, so the relay clicked. Again. Off. Go ahead. Okay. Our relay is clicking. So again, we have our relay clicking. Now on the back side of the pump back here is our actual connector. You can turn it off for now. I'm going to go ahead and unplug the connector. Let's take a peek at what we have going on here. Oh. All right, so is this, figure out which one's connector side and harness side. All right, so I think you guys can see that. Yep, there we go. This is the harness side. So let's take our meter and see if we got voltage. Thank you. Hey, look at that. You can see it. All right, just real quick. All right, off. That's odd. We got 1.2 volts on there right now, and it's, oh, get my arms out of the way. On. Okay, we got voltage. Off. Huh, we still got 1 volt sitting on here right now. Well, isn't that interesting? All right, so we know we got power down there when we're supposed to. We know this thing is able to power it up. Man, I wish this fan would shut off. We know it's able to power up, but we don't know if it's able to pass any current through it yet. So let's, again, we'll just grab our headlight, 6 amps on a 35 or 40 amp running pump should suffice. We'll kind of hide that up here. Again, hopefully not drop it. And could you go ahead and turn that on for me? Off? On? My relay's clicking, but we got nothing. Okay. So this is where it gets interesting, right? We're not passing any current through this thing. It's not doing its job. We have voltage there, but we have no current. Now this is where voltage drop testing comes in handy, right? If you would have just replaced a pump after you check for power, this car's coming back. It's coming back in a day or two, or whenever it runs the test next. It's going to have issues because, and actually, I don't have any power feeds down here right now, but we could run this pump, and this pump will function. Let's go ahead and turn the meter back on. There we go. And I believe one of these big red wires here, actually, let's move these out of the way. See if there's any water in this thing. Hey, no water. That's a good sign. So we got no water in this one. That's a plus right off the bat. And you guys should be able to see the relay now. There's our relay. Big old relay, 2 big wires going to it. Let's see if this is our input side, which would be powered up at all times. 1.2 volts. Let's look at our other side. Nothing. Can you go ahead and turn it on? Nada. Well, this is interesting, isn't it? Turn it off. So one of these should show power here. Because in our wiring diagram, one side of the relay is turned on at all times. Right? Going to our relay, it is a direct 60 amp fuse going to this thing. And I know I have power there. I must just have a bad connection somewhere. Let's see if we can find a non-rusty ground. Easier said than done sometimes. One volt. Well, maybe. There we go. Bad connection. Another reason why I suppose I should be piercing my wires, but all right, so there's our inlet side. We are showing 11.78, which is battery voltage currently on the input side. So if we were to do the good old voltage drop test, what we're going to do here, if we go ahead and look up the wiring diagram, what I want to do is I'm going to go ahead and you could go from anywhere on the power side. You could start at the battery for all you want, but you want to check the same side of the circuit while it's energized. So I'm going to just go ahead and stick one lead in here and my other lead in here and see if we're dropping our voltage across our relay. Our relay may be the problem. That's maybe what I'm suspecting to be our problem. We could have bad wiring somewhere else. But let's go ahead and do a voltage drop across the relay. So right now we're just going to measure the difference between either side of the relay. So when it's off like this, we should read ground, or we should read 12 volts, because if we look, if it's off like this, we should, here we're hooked in, and here we're hooked in. We should read 12 volts right now because this is grounded at all times if I had the connector plugged in. So I plug our connector back in. Again, when you're voltage dropping, you need to have the circuit intact, and you actually need to turn the load on. But with a path to ground, there we go. So across our relay right now, we're dropping 11.77 volts, which I would expect to see. That's normal. That is what we'd expect to see when the relay is not energized, because again, pin 30 has 12 volts at it at all times, and pin 87 is currently directly connected to ground through our secondary air injection pump. Okay? So as soon as we turn this guy on, there should be no difference across our relay. Our meter should go practically to 0 because our load at this point consumes our voltage, not our relay. So if we see anything other than 50 millivolts, under 50 millivolts, if we see anything higher than that, we have an issue on this relay. Let's go ahead and turn that on and let's take a look. Is it on? I heard it click too. We're still reading battery voltage. Okay, again? So even though our relay is clicking, doesn't necessarily mean that it's working. Let's give it a couple taps. Is it on? So still nothing. Okay, you can turn it off. So even though our relay is currently turned, while it was turned on, we were still dropping our full voltage across this relay. And I know you guys probably can't see it yet, but I can see a burn mark on this relay. But let's just verify real quick with a piece of wire. Make sure this pump works. Because again, right, you checked for power and ground. If you ordered a pump and installed it, this customer is going to be back. Let's see here. Well, I would say that our pump's working just fine. Our pump is pumping, it's doing its job, it's creating air, but our relay right now is failing us. Let's see what it takes to get this guy off. A 10 millimeter socket. So even though we had voltage, power and ground, going to our secondary air injection pump, if that's all the further you go with the test, you are going to be in trouble. We need to verify that the system is able to move current, is able to flow current through it. Otherwise, you are going to have an upset customer who's going to be coming back with the exact same complaint. This pump, so far, shows nothing wrong with it. And of course, I backed my relay up against the connector, or my ratchet up against the connector here. Oh. Uh-oh. Houston, we've got a problem. Well, I think I found where that smell's coming from. It is stinky. Here. What do you guys think? That's a known good relay, huh? Look at the underside. Oh, maybe. I'll get some pictures with the microscope of this thing, but there's actually melting. Maybe. Can you see that? Grab a flashlight. There's actually melting going on. There. Look at that. You can see it's burnt. There's definitely some melting happening here. This relay is toast. Now, the question is, what caused it? Did the relay go bad and cause this, or did the... I don't know if we're going to be able to open this up today. I was hoping... Yeah, we'll save it for the Tech Connect. I'll have this thing opened up and we'll look at it under the microscope. But, again, secondary air injection. Is this the cause or the effect of the problem? Let's take and... magic parts again. Let's take and install a new relay on here, and let's do some current testing on this thing and see what this pump pulls. One other note, guys. If we look at this connector, and you might not be able to see it, but there's burn marks on this connector, and this pin right here is showing burn marks and a slight amount of corrosion. We have an issue with this connector. Let's go ahead and plug this in. Just for now, this is temporary. I'm not going to bolt it up, anything like that. Can you go ahead and cycle it on for me, please? Okay. So we saw the meter right here go down to like, what, 48 or 46 millivolts. That is our voltage drop across the relay at this point. That means that we're not losing voltage crossing our relay, meaning we're giving the full voltage over to our pump. Our pump is consuming our full amount of load. So our new relay is functioning. But guys, this is where you need to have a conversation with your customer, right? This is where, sir or ma'am, I found a bad relay on your vehicle. This relay is melted. This is going to allow the system to not function. But you also have a pigtail that is starting to show burn and corrosion, and that could be a cause of high resistance in the future. Would you like me to replace that as well? Our customer chose to replace it. Unfortunately, I don't have the new connector here today, but it will get replaced as soon as the new connector shows up. So this thing for sure needs a relay. I would recommend a connector, but again, it's up to your customer. But let's take a peek at what amperage this thing actually draws for this system. So our other, I don't know if this is going to be long enough. Nope. Our other system on the BMW drew a peak of 105, I believe, amps. Let's see what this one does. Now this is the original, This is the original pump on here. think I put my hook away. I don't know. Not enough range. Could you hold this for me, Peter? Thank you. Guys, it's good to have Peter around here to help out. Let's separate this out a little bit, and I just want to grab one of these big power wires here and just current clamp it and see what we got. All right, let's start this back up. I'll leave all the settings the same. I'll turn off these other channels. We're only going to look at one channel. You can bring up the lab scope. Come on. All right. Bring that up to 0. Okay, go ahead, turn that on. Whoa. All right, off. Let's do that again. All right, off. Oh, look at that. $130. Yeah, we'll call it 130. That looks pretty close, yeah. 130 amps this thing pulls on initial startup. Now, it only does that for a very short amount of time, but that's still a huge amount of amperage. Let's see how long it stays above its fuse. So here's 60 amps. Call it right about there. So what is that? 1/3 of a second or so? 335 millivolts, milliseconds. So 1/3 of a second or so. It stays above its control. So this pump right now that's on this vehicle is drawing 130 amps at peak turn on. Let's compare it to a new one. Let's see what we got. I have a new one here. I don't think this thing's going to need it. I think our pump on here is okay, but let's just compare it to a known good and see what we've got. That way you guys have the spec on a known good pump as well. This thing is brand new. This is not a reman pump. It is completely brand new. Let's go. And like so. And we're still going to be connected in the same place. I'd really rather not leave this hang here. Might just have to for this. It'll just run for a second. Yep. Oh, I got it. And we'll get rid of our cursors. Okay, let's bring up the scope again. Let's see what a new one runs. Whoa. That one even higher. Go ahead. That time it was lower. Let's let it come to a full stop. I think it takes a while to wind down. All right, go for it. All right. So it's pulling, the brand new one is pulling even more, 145, 146 amps. And then consistently, these things are pulling, call that consistent, 30 amps. Look at that, 30 amps right there, 31 amps, which is in spec, right? The GM spec is between 35 and 40 amps to draw on this thing. So this pump that is on the vehicle in comparison to our known good, they are both fully functional. I don't think we have any other issues with this system. The solenoid is okay. That one is opening and closing okay. It is a brand new part that the customer put on here. The problem in this thing was a bad relay. Set this back off to the side. I don't think I'm going to recommend to the customer to put a pump on this one. I mean, it's up to the customer at the end of the day, but I think the proper fix on this is a new relay, a new pigtail, and I think it'll be good to go. Again, up to the customer if he wants to put a pump on it or not, but the amperage specs are in spec, and the peak is about equivalent to a brand new one. So that is that. If you have voltage at your pump, you might not be able to pass current. That's where voltage drop testing comes in. We have to make sure that we are fully testing this. All right. So, magic parts again. Let's see. Anything else that anybody else wants to see on this thing with the lab scope, voltmeter, scan tool? Anything else that you guys are looking for to be able to see on here? Otherwise, I think it's about time to wrap it up. It's been almost an hour and a half here. Adam1 here says, new bearings have more drag than older ones. Sure, right? The new bearings are packed nice and tight in there. Could be a little bit stiffer of a turn, a little bit harder to turn. It's going to draw more amperage. Makes sense. Break-in time for the new pump. Sure. All right. Man, this is like watching a cooking show where they magically take an already baked cake out of the oven. It is almost just like that. A lot of times, guys, these cars have to come in ahead of time. We'll usually diagnose them ahead of time because I need to be able to have the parts here to show you guys known good. It's just kind of nice. I feel like the video would be incomplete if we weren't able to show you guys a known good at the end. We kind of leave you hanging. Would have to do a part 2. So I like being able to have the parts here, and I'll usually have more parts than necessary. I'll usually order one part for each of the system and then return what I don't use. Pull a known good cam and crank. I might just do that. It's a good thing if you guys ever have 5 or 10 minutes. Some take longer. But to pull known good cam and crank correlation off of a vehicle that's not currently coding, it's always a good thing to do when you bring it into the shop. That way you end up with a database full of known goods when you're diagnosing VVT issues or something on these 4.2s. All right, guys, I think that's about it. Thank you, Peter, for all your help today. Looks like Bob's got to go. Time to get back to work. All right, guys. Thanks for watching. I hope everybody has a happy holiday season. We have a couple more videos coming out yet before the end of the year, but then make sure to check back the first week in January for the next one when we go out live, and then Peter will be starting up some Spanish training as well. So that's going to be it for today. The magic parts aren't real. Darn, huh? I kind of wish you had like a magic screwdriver or something. You just have to wave it and parts would appear. That'd be pretty sweet. All right, guys, that's going to be it. Thanks for watching. If you liked what you saw, please give us a thumbs up. Subscribe. Shoot me out an email. It's right here. Shoot me out an email with your answer to the t-shirt giveaway question. If you were paying attention, I think you should probably have the answer. But go ahead, shoot me out an email with that. And check us out on social media, Facebook, LinkedIn, Instagram, and Twitter. Search for Wells Vehicle Electronics or follow the links that are down below in the description of the video. That's going to be it, guys. And have a safe and happy holidays if I don't talk to you before then. And we'll see you guys after the first of the year. Have a great day and happy wrenching, everyone. Thank you.